I'm just going to give you a few hints here on your homework assignment. There are a few of the trickier problems towards the end of section 8-3. And I want to discuss with you how to do numbers 43 and 45. And in order to do that, I'm going to do a sample problem for you for number 44. So the trick that the book gives you hints to is that we know that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Okay. That's simple enough. We've been using that for a while, and we're probably getting pretty close to memorizing it if we haven't just written it down on our reference sheet and look it up all the time. I'm a big fan of that reference sheet. I'm not going to ask you to memorize this one. Don't forget that. But let's say we want to change that up a little bit, and I'm just going to do a simple substitution here to help you see something that the book did, just in case you didn't quite catch it. And that is, I am going to say that a is equal to the cube root of x, and b is equal to the cube root of y. Okay. Well, when I make that substitution into here, I'm going to find that I need a cubed. Well, x, the cube root of x cubed is just going to be x, and the cube root of y cubed is just going to be y. So I have x plus y. And then over here, I remember I can also write that as x to the 1/3 power. So instead of a, I'm going to write x to the 1/3 power plus y to the 1/3 power times x to the 2/3 power plus, I'm sorry, that's a minus x to the 1/3 times y to the 1/3 plus b to the 2/3 power. Now I know I wrote my fractions the wrong way, but I'm doing that just because my marker is making it difficult for me to keep that all together. So that's how they get the second equation in the book from the first equation. They just do a substitution like that, except instead of saying it's x to the 1, once they did this, they changed everything back to a and b. But it's really the same thing if you think about the algebra. Oh, and this should have been y right here. That should have been a y to the 2/3 power. So how do I use that to solve this? Well, if we think about this, our problem from the book is actually 1 over the cube root of 4 plus the cube root of 5, right? Cube root of 4 plus the cube root of 5. If we think about that, that cube root of 4, well, if x was 4, this would be the cube root of 4 plus the cube root of 5. So this part of it is exactly like the denominator of the problem that we want to go ahead and rationalize, because we don't like those square roots in the denominator. So if we think about that, let's just substitute, or not substitute, but let's get this y, this term by itself so that we can do a substitution. And what we find is that x plus y over all of this stuff over here, x to the 2/3 plus x to the 1/3, y to the 1/3 plus, I'm sorry, I do that all the time, minus x to the 1/3, y to the 1/3 plus y to the 2/3 is going to be equal to x to the 1/3 plus y to the 1/3. These two expressions are exactly the same. Okay, I know my writing, and this might be kind of hard to see in the video, but you kind of get an idea of what I'm doing. Well, that means that I have a new term for which I can rationalize. Let's come back to our problem over here. Okay, there's our problem. And we know that we want to rationalize this. And to rationalize it, we are going to multiply this by 1 over the cube root of 4 plus the cube root of 5. And we know that on the top of this fraction, we need to have exactly the same thing that's on the bottom, right? So we want to, if we use this definition over here, we can think that instead of x to the 1/3 y, we could say that that is 4 to the 1/3 plus 5 to the 1/3 is the same thing as 4 plus 5 over 4 to the 2/3 minus 4 to the 1/3 times 5 to the 1/3 plus 5 to the 2/3, and that's all in the denominator. We can make that substitution if we realize that our denominator was exactly the same as that. You agree? Okay. So if we want to multiply by 1 over this, that's the same thing as multiplying by the inverse of this expression, right? Because this is the same thing. So if this is the same thing, I'm sorry, I'm running out of room on my screen. If this is the same thing as this, then 1 over this will be the same thing as this flipped upside down. So instead of writing 1 over the cube root of 4 plus the cube root of 5, I can write 4 to the 2/3 power minus 4 to the 1/3 power times 5 to the 1/3 power plus 5 to the 2/3 power, all divided by 4 plus 5, which is 9. These are going to cancel off, and I'm going to be left with just the numerator. And that numerator will simplify. I will have up here, it's just 1 times all of that stuff, right? So it's just going to be 16, the cube root of 16, because we have 4 to the 2/3. So 4 squared is 16, and the 1/3 power is the same thing as the cube root, minus 4 times 5 to the cube root of that, and plus the cube root of 25, which is the same thing as the cube root of 16 minus